Okay, so in this video, we're going to talk about vertical, horizontal, asymptotes, and then points of discontinuity. So remember that a vertical asymptote is whatever makes the denominator equal to 0. So the function is going to be undefined there, and what that results in is a vertical asymptote. A couple graphs that you should be familiar with are the inverse graph and the inverse squared graph, which both have horizontal and vertical asymptotes, but they are undefined in their denominator. So for an example, if you have y is equal to 2 over x plus 7, so where the denominator is 0 is where you would find a vertical asymptote. So that means that you would have a vertical asymptote at x is equal to negative 7. So this is not a number per se or a ordered pair. It is a vertical line where the graph does not pass. Okay, it cannot go because the graph is undefined there. So horizontal asymptotes, you have 3 scenarios with horizontal asymptotes. You have little over big. So for example, 1 over x. And this is always going to give us a horizontal asymptote at y equals 0. You have big over little, which would be like x over 1. And this is going to just get big without bound, so this is undefined. And then you have same over same, which means you have the same degree in the numerator as the denominator, so like 3x over 2x. And that's always going to be y equals the coefficients. So for this example, y would be 3 over 2. So the numerator over the denominator, the coefficient of the like terms. And for a point of discontinuity, this means that you have the same factor in the numerator as the denominator. So if you had factored x plus 1, x minus 3, and x minus 3, and x plus 2. So because these two cancel here, that means that my POD is actually located at x is equal to 3, whereas x is equal to negative 2 is actually a vertical asymptote. Okay? So let's take a look at some example problems. So it says for us to identify the VA, HA, and POD, so vertical asymptote, horizontal, and point of discontinuity. So before we can really do VA and POD, we have to factor, but we can go ahead and find our horizontal asymptote because that's based off the degree of the numerator and the denominator. So if you look here, PODs, this is a third degree over a third degree, which is same over same. So this means that I'm going to have a horizontal asymptote that is the ratio of the coefficients. So that would be 4 over 1, which obviously is just 4. So I have a horizontal asymptote at y is equal to 4. So now to find my vertical and POD, I need to factor. So my numerator factors with a GCF of 4x. That's going to give me x squared minus 5 over my denominator factors with the GCF first. So then I have y is equal to 4x times x squared minus 5 all over x times x plus 8 and x plus 2. So notice here, I have an x and an x. Those would cancel out, which makes my POD x equals 0. Then I have these two remaining factors, which would both be set equal to 0 to find my vertical asymptote. So x plus 8 equals 0 and x plus 2 equals 0, which means I have vertical asymptotes at x is equal to negative 8 and x is equal to negative 2. Okay, so same thing. We can do VA, HA, and POD. So horizontal, I'm going to start with horizontal. So this is little over big because I have an exponent of 1 and an exponent of 3 in the denominator. So that would be a smaller exponent in top over a bigger exponent in the bottom, which means I have a horizontal asymptote at y equals 0. To find the rest, I need to factor. So I have 2x over x times x squared minus 4. So very similar to the last problem, I have an x and an x, so that means that my POD is x is equal to 0. Then I have this factor, which would give me my vertical asymptotes. So x squared minus 4 is equal to 0. Now you have a couple options. You can use square root property or you can factor. I'm just going to use square root property. So that gives me that x squared is equal to 4. So x is equal to plus or minus the square root of 4, which means x is equal to plus or minus 2. So I have vertical asymptotes at x is equal to 2 and x is equal to negative 2. Okay, so again, VA, HA, and POD, right? So I'm going to start with my horizontal asymptote. So this is big over little because I have 2 over 1. So the exponent of 2 is larger than the exponent of 1, which means that this is undefined. Now, if you remember back to Algebra 2, you can have an oblique asymptote here. We just don't deal in them often. Okay, so to find my VA and my POD, I would have to factor. So I have y is equal to x minus 5 and x minus 3 over x minus 5. So these would cancel, and that is what's going to give me my POD. So x minus 5 is equal to 0. So x is equal to 5. So that's my POD. My VA, however, there is nothing left in the bottom, right? So there's nothing left to make that denominator 0, which means there is no vertical asymptote. Students will oftentimes overcomplicate this problem. So let's just look. VA, HA, and POD. There's absolutely no chance to have a POD because there's no x in the denominator. So there's none. The same is true with VA. There's no x in the denominator. There's none. 7 is not a VA. In fact, if you rewrite this problem, it may make it more obvious that this is in fact a linear problem. So it's definitely not going to have a VA or an HA. It's also not going to have a vertical asymptote. It's going to be undefined because this is going to continue forever and ever in both directions. Not going to have any kind of asymptotic behavior at all because it's a linear function.